Now f is a real valued function and it is satisfying a functional equation f of x plus 2y equal to f of x into e to the power of 2y plus f of 2y into e power x plus x square into 1 minus e power 2y plus 4y square into 1 minus e power x plus 4xy. And another value given is the derivative of f at 0 is given, that is 1. Now using this functional equation and the derivative at 0 to be 1, we are supposed to find the function f of x. Now what is the functional equation that f of x is satisfying? Yes, f of x plus 2y is equal to f of x into e to the power of 2y plus f of 2y into e to the power of x plus x square into 1 minus e to the power of 2y plus 4y square into 1 minus e to the power of x plus 4xy relation. Now to explore this function, let's put x and y values as simultaneously zeros. What will happen to the functional relation? We get f of 0 equal to, this part would become f of 0 into 1. This will also become f of 0 into 1. But this whole term would become 0. This term would become 0. And this term will also become 0. That means we get 2 times f of 0. So can we conclude that f of 0 value is 0? So we are able to identify the functional value at 0. Now, as we know the functional's derivative at 0, let's first calculate what is f dash x. Then by definition this is limit, yes, as h tends to 0. Remember that h I am treating it as 2y. Then limit 2y tends to 0, f of x plus 2y minus f of x by 2y. As we have an expression for f of x plus 2y, let's replace that expression given to us. Then this equation should satisfy limit 2y tends to 0. What is f of x plus 2y? F of x into e to the power of 2y plus f of 2y into e to the power of x plus x square into 1 minus e to the power of 2y plus 4y square into 1 minus e to the power of x plus 4xy. This is the expression for f of x plus y minus f of x whole thing by 2y as 2y tends to 0. Now let us proceed to simplify this further. This would give us limit 2y tends to 0. When we take f of x common from the first factor and the last factor, this is f of x into e to the power of 2y minus 1 plus, when we collect e to the power of x common, that becomes f of 2y minus f of 0 minus of x square into e to the power of 2y minus 1 plus 4xy. And what are the terms left? Yes, the collection of 4y square terms. 4y square into 1 minus e to the power of x divided by 2y. Now let's split the function as the limit of y. Then the first function, first part, f of x is a function of x, but the limit is on y. So this is f of x times limit 2y tends to 0 e to the power of 2y minus 1 by 2y plus, again e to the power of x is a function of x, so bringing it outside the limit, this is limit 2y tends to 0 f of 2y minus f of 0 by 2y minus of x square is a function of x, so unaffected by limit, then into limit 2y tends to 0 e to the power of 2y minus 1 by 2y plus 2y and 2y cancels here. The rest is only 2x, which is independent of limit y. Therefore, it's a constant. Then again, 4y square into 1 minus e power x by 2y would make it 1 minus e power x into limit 2y tends to 0, 2y, right? So if you clearly observe, this limit is 0. And the rest of the limits are all in the standard forms. What would be the limits coming up? So the calculation of f dash x would give us f of x into limit is 1 plus e power x into, yes, that is by definition f dash 0 minus x square plus 2x. But in the data we have the value of f dash 1 also, that is f of x plus e power x into 1 minus x square plus 2x. This is the value of f dash x. Now once we have f dash x as a function of f of x again, how do we get the functional value of f of x. Yes, don't jump to finding the integral on both sides because there is still an unknown function f of x here. So let's do a simple manipulation on this. When we multiply the throughout equation by e power minus x, what do we get? E to the power of minus x into f dash x minus e to the power of minus x into f of x is equal to e power minus x into e power x1 minus e to the power of minus x into x square plus 2x into e to the power of minus x. Now what did we do by multiplying with e power minus x? Yes, the derivative of e power minus x we created with this factor, and though this is dy by dx of e to the power of minus x into f of x is equal to, the right hand side is the dy by dx of x plus x square into e power minus x, right? Now by taking integral on both sides, we get e to the power of minus x into f of x equal to x plus x square into e power minus x plus c. Now once we have identified that f of 0 is equal to 0, when we replace it here, we get the value of c is 0. So again when we use this is e power minus x into f of x is x plus x square into e to the power of minus x, as we need only f of x. Let's multiply this equation throughout by e power x. Then this is x into e to the power of x plus x square into 1. So have you got f of x function? What is f of x function? X into e power x plus x square, which is present at option A. By using the functional relation and the first principle definition of derivative and some standard limiting values of e to the power of x minus 1 by x, we used these two results to find the function f of x, right?